Today I'm going to talk to you a little bit about Unity's new dots system. Is anybody out here already using dots for anything? Okay. Myself, I really like games that have really frenetic gameplay, lots of fast action, sprites, things exploding everywhere, there's tons of particles. I grew up on arcade gameplay, and that's still what I like today. Presenting those kinds of games in Unity presents a real performance challenge, which is why I got interested in the dots system, which is currently in preview. I've been doing some experimenting with it, and I'm just going to talk to you a little bit today about what I found out, what it is, how you use it, and why you might want to use it in your projects. So, DOT stands for the Data-Oriented Technology Stack, and this represents a fundamental shift in the way Unity do things. In simplest terms, currently in a Unity project, you will make a game object instance. It's going to contain its own data and perform its own operations individually on it. Under the new DOT system, you will actually create entities that contain just the data and a separate component system to actually perform operations on that data. So it's moving the Unity pipeline away from an object-oriented approach to a data-oriented approach. So basically, the data-oriented technology stack is broken up into three systems: the entity component system, the job system, and the burst compiler. It is in preview right now, so if you want to play around with it, you need to get the Unity 2019, any version. You want to go into your package manager, make sure you're showing the preview packages, and you want to add burst, collections, entities, the hybrid renderer, the job system, and mathematics to your project. So the entity component system, well, what exactly is this? I said previously, your entities are going to hold component data. You build your entities out of archetypes, and they can each contain multiple different components. The components themselves are simply structs, and all they're going to hold is just the data you need for individual system operations. Systems are a class that extend the component system, which is again part of the new Unity entity system. You build a component system, and it will have an on-update function, not update the way you have in mono behavior now, but on-update. Simply having the component system made and having the on-update in it will cause it to work from anywhere in your project. You don't need to add it to a scene or a game object, so you probably want to make sure you have something in there that makes sure it's not doing things when you don't want it to. So just, how do you work with this? And I'd like to just walk through how you might theoretically put together a game like this. So let's just say we took a handful of components and we want to make a game entity out of them. First thing we're going to get are the translation, rotation, local to world, and render mesh components that Unity have created. And they're in the new Unity transforms and unity.rendering packages. These are specifically made for the entity component system and are much more performant than what you currently have in Unity. Then you yourself are going to want to make a handful of components to do custom things in your game. So just for the sake of argument, we'll say we want to have a movement, a soldier that will be our player, tanks that will be our AIs, the ability to shoot bullets, the ability to do damage to something, and the ability to take damage. So we'll just make individual components for all of that, and they will just be very basic. The movement will probably just be a vector and maybe a speed to control that. In this case, the example I'm doing, shoot bullets, would just probably have a bool in it that says whether or not to shoot. Your does damage would have just the damage it's going to do. Your take damage would have just the hit points left it could take. So you could take those components and construct three different entities from them. So for our player, the soldier archetype, we would put together our soldier component, which will identify to other systems that this is the player soldier character. You could also put a thing in there like hit points, speed, things like that, although in this case, I'd be putting the hit points in the takes damage and speed in the movement. Similar to the tank, we put the same components on it, except we'll put the tank on it instead of soldier, and that's going to identify to the system that this is an enemy AI unit as opposed to a player. And then for our bullet, all we're gonna need on that is a movement property or a movement component and does damage. So, am I making any sense so far?
Yeah.
All right. So, once you've done that, you need to make some systems to do anything useful with any of this data. So, the first thing we do would be make a player control system. It's going to be a very simple update function that just looks at the player controls, and for every object that has the soldier component on it, we'll say, okay, what do the controls say I should do? And they will pass that to the movement. So if it's move left, they will send a vector for left to movement, just set its value, leave it alone, and check to see if the fire button is pressed, in which case we would update our shoot bullets to just say true. Very similar thing for the tank, but instead of player controls, we would have that tank component work in an AI system that is going to do things like find a direction to the player, head towards it, decide whether it's going to shoot, and it's going to do the same thing with as the soldier does. It's just going to set those values in the movement and shoot bullets components. Then we'll have a shoot system, and all this is going to do, it's just going to sit there and listen for everything that has the shoot bullets component attached to it. So in this case, our player, all the tanks, it'll see the shoot bullets. The one update is going to iterate through all of those, and for any that are marked yes, shoot a bullet, it's going to instantiate that into the scene, and then just mark that to not shoot. So we have to wait for another input on that. Once all that is done, and our player is moved, our tank is moved, and we spawned any bullets, the move system takes over, just looks for everything in the scene that has a movement component on it, and just moves it by that value. Finally, a damage system that iterates through everything that has a does damage component on it, and checks that against everything with a takes damage component on it. So basically we end up with a loop that first checks our player controls, and looks at our tank system and moves them, spawns any bullets into the scenes, moves things, checks for damage and hits, and then just moves on from there. Now, at this point, you're probably asking, well, why would I want to jump through all those hoops instead of just using the existing Unity systems that are there? First answer is it's a better way to organize your code. You can just build a very simple system that works on a type of data, and you can just add that component and remove it from entities that are in your scene to give effects to them. A guided missile type behavior, for example, you could just put a target component on it, and all it holds is its target, and as long as it has that target component, its system will move it towards the target. Makes the code quite easy to reuse, and it's very easy to take complex or build complex behaviors out of very simple systems. But also, there is an amazing amount of performance boost to be had through this system. Unity are reimagining the way they build games, and everything in the entity component system is optimized. So at this point, even if you're not using the job system or the burst compiler, but just any component system, at this point you're already going to see a lot of performance boosts. I'm primarily working on 2D sprite-based games, and I can get thousands of sprites drawing, doing distance detections to players and steering behaviors to find them, and I'm still getting frame rates in the 60 zone. It does currently integrate with, or it does integrate with the current Unity pipeline, so you can use this system to do things that are very intensive. You don't necessarily have to move your entire game into them. So Things like your UI or any existing plugins that you are using are still going to work, and the two systems can talk to each other. It also is the way forward into the future with Unity, though. They are in the process of changing everything in the engine to work in this system as well. The new Project Tiny system is going to work exclusively on ECS. And that's good for doing, small hyper-casual things, Facebook instant games, etc. And also, there's very easy integration with this style of coding into the Unity job system. So what exactly is the job system then? So the job system, according to Unity, the C# job system exposes the native C++ job system, allowing C# scripts to be jobified alongside Unity internal components. And really that just means it's a very easy way to create multi-threaded code inside of C#. It also provides a safe environment that avoids most of the pitfalls you experience with doing things multi-threaded, such as race conditions. The way the job system works, it's also good for it's also ideal for repetitive recursive operations. So the way the job system works is we simply define a job. So we would take one of our component systems and set it up as a job. And then within your main update loop, you just want to schedule a job. You do this all in the order you want to have your order of operations. So you would schedule a job, pause the main thread, wait for that job to report back as complete, and move on to the next one. You just do that for all your desired jobs until everything has been moved or affected. And that, again, for anything that's taking up a lot of time that has to do the same operation over again, so hit detection, path finding, physics, these sorts of things can be sped up incredibly by moving it to the job system, and instead of doing one operation at a time, it'll spread them out in parallel across all the threads you have available. Then the final step in this process is the new burst compiler. You can use the burst compiler for the things you put into jobs, and what it does, it converts your C# job that you've written into highly optimized machine code, and will perform specific optimizations for the target platform you're compiling for. And this gives a further boost in the performance. So the performance gain you get from this really is quite amazing. I really didn't bring any code examples today. There's a lot of tutorials and examples on the web that are probably far better than I could do for you here today. So if you're interested in using the system, I would encourage you to go take a look at some of those. There's a YouTube channel, Code Monkey. They are very excellent. There are also a lot of other tutorials, and Unity has a GitHub repo with all sorts of examples of jobified code, so showing the different ways to do things and what the different systems are. I went through that way too fast. So, to sum up, the data-oriented technology stack is great for doing things like voids and flocking behaviors, pathfinding, physics simulations, writing your own particle systems, hit detection, complex math, anything that's really recursive can be just fed into that job system and comes back so much faster. Any questions? Yeah.
You mentioned the performance gains that you noticed from ECS. Did you get any idea of, like, say you had an existing code base? So you mentioned the performance gains you were getting from ECS alone.
Yes.
And I was curious, like, say you had an existing code base, did you find or do you think there would be any benefits to using, say, a hybrid ECS as opposed to starting from scratch? Using a lot of behaviors?
Well, I think it would depend. I think it would depend on the specific situation. If you're going to actually use the ECS renderers and stuff, I think that you would see benefits there, even interacting with other mono behaviors. I have played around a bit with just positioning things, traditional game objects in the scene with data that I'm pulling out of an ECS system. And there's definitely an improvement in that. You don't quite see the rendering boost with that you do with the new render mesh. Anyone else? All right. Sorry, Daryl. I told you that was never going to be a half-assed.